Hello everyone, welcome back. So let's continue with our discussions on vectors. So, okay. So before we continue and discuss about components of a vector, let's do a simple problem from the previous lecture. So we have seen this parallelogram in the last lecture, uh, which was made up of A vector and B vector, and the resultant diagonal was the A plus B vector. So A vector, B vector, and we can draw the B vector here also, redraw it perhaps. So, and A vector. So we have already established this main diagonal was A B vector plus A vector or A vector plus B vector, right? So our question now is, what is the other diagonal of the parallelogram? Let's say directed from here to here. Okay, let's figure out what is this diagonal. So this is the question now. So let me name our quadrilateral as PQRS. Okay, so to figure that out, we can mark, let's say in triangle, PQS. We want to find out what is SQ vector, right? Like, what is SQ vector? So SQ vector, to go from S to Q, you can choose two paths. So one path can be, I can go from S to P and then from P to Q. Okay, so it is equal to SQ vector is equal to SP vector plus PQ vector. PQ vector we already know. PQ vector we already know that this is A vector. But what is SP vector? SP vector is nothing but negative of B vector. Okay, and in the same way you could have chosen the alternative path. Let's say in triangle P RSQ, we want to figure out what is SQ vector. So to find SQ vector, we can go from S to R and then R to Q, right? So SQ vector is nothing but, we can go from SR and then plus RQ. We already know SR vector. SR vector is nothing but A vector. But if you see carefully, RQ vector is in the opposite direction of B vector or QR vector. So it is negative of B vector. So from both of these, we can say the other diagonal is nothing but A minus B vector, right? A vector minus B vector. Okay, so we have a complete picture of our parallelogram. So complete picture of our parallelogram looks like this. So A vector, B vector, B vector, A vector. So the diagonal from this edge to bottom left edge to top right edge is the A plus B vector or B plus A vector. And if you want to draw the diagonal from top left to right, bottom right, and this is A minus B vector. And opposite direction में क्या होगा? अगर if you go from bottom right to top left, that is B vector minus A vector, negative of that, of course. Okay. So let's start our discussion from NCERT. Components of a vector. So I'll take a diagram from NCERT. So this is the main diagram. Okay. So let me enlarge it a little bit. Okay, so we will start by defining three orthogonal vectors I, j and k. So this is a unit vector because you can see the cap on the top of it, I cap, j cap, k cap. So this is a unit vector along x axis. This is a unit vector along y axis. And k cap is a unit vector along z axis. So as I mentioned कि these are unit vectors and we know already किसी भी unit vector का magnitude कितना होता है, 1 होता है. So magnitude of I cap is equal to magnitude of j cap is equal to magnitude of k cap, and all of them are equal to 1. So this is just a definition. We have named these three orthogonal vectors, orthogonal unit vectors. Orthogonal means they are perpendicular to each other. So why have we specifically chosen these three? Because if we choose any three vectors which are linearly independent, that they will span the whole three-dimensional space. So that might be you might hear a little bit of jargon here, but this is from the advanced topic of linear algebra. But let me write a statement here which maybe you can relate to. So I cap, j cap and k cap can be used to construct any vector in three-dimensional space, any vector in 3D space. Okay. So you can see in this diagram, where is I cap? So I cap is like we have moved from our origin, which is at 0, 0, 0 to 1, 0, 0, and so this is along x axis. And if we move from 0, 0, 0 to 0, 1, 0, this is along y axis, we will move, this is called j cap. And if we move from origin, so if we move 1 unit in the direction of z axis, so to the point 0, 0, 1, this is called k cap. Okay, so let's do a very simple 2D example. To let's say this is my y axis, this is my x axis. Okay, so now let's say I want to draw, I want to know what will be a vector that joins origin to this point. So let's say this point is, so we can look here 1, 2, 3, 4, 4, comma 2. Okay, this point is 4, comma 2, and origin is O, which is at 0, 0. So how can I reach at this point? So I can reach at that point in many different ways, right? And nobody is stopping me to reach this point. I can go here, then here, then here, then maybe here. I can go here directly. I can go from here to here. But we will simplify our lives by using triangle law. And what I will do, I will go along first a vector, right? So a vector along x axis, and then a b vector along y axis, right? Okay, a vector and b vector. We already know from the triangle law that the third side from the initial point origin to the final point 4, comma 2 will be a plus b vector, right? Okay, from triangle law. Okay, so what is a vector? If we look carefully, we have defined I cap, right? I cap is if we move 1 unit along x axis. But how many units we have moved? We have moved 1, 2, 3, 4. Okay, so This is 4 times I cap. Okay, what is B vector? B vector, so we have moved 2 units, but in which direction? Along y axis, right? J cap. So we can define OP vector as A vector plus B vector, which is 4 I cap plus 2 J cap. So 4 with I represents I have moved 4 units along x axis, and then 2 units with 2j cap represents I moved 2 units along y axis. Okay, so I could have moved to the same point using a different trajectory also. I could have moved along j cap first, then along I cap later. So in that sense, our OP vector will be nothing but, let's say, this A dash vector plus B dash vector. So what is A dash vector? A dash vector is, so we have moved here how much? 2j, right? We have moved along y axis and 2 units, right? Okay. So from this we can say twice of j cap plus 4 times I cap, which is basically the same result as this, right? We always write it in order I, j, k, so we will rearrange it. So OP vector is 4i plus 2j. So in that sense, we can write now any vector in 2D space, and let's see the example of 3D. So we will take this cuboid from the NCERT and see how can we define a vector joining origin to the point P, X, Y, Z. Okay, so let's take this cuboid. Okay, so our main aim is to find what is this OP vector, right? We are going from origin 0, 0, 0. Okay, so well, there are many number of ways to do that. So one of the method might be कि I first go along OQ vector and then go from Q to P1 and then go from P1 to P. So it doesn't matter. I have chosen first to go along x axis, then y axis, then z axis. Nobody is stopping you to go along y axis first. So if we look carefully here in the previous illustration, to reach the point 4, 2, I have to move 4 units along x axis, then 2 units along y axis. Okay, so what is the projection of OP vector on x axis? It is 4, right? It is the x component, right? Okay, and 2 is the projection on the y axis, right? Okay, this is projection. So this particular one is projection of OP vector on x axis. Okay, so to reach this point xyz, I will first move along OQ vector, right? Okay, so OQ vector is nothing but x I cap, right? So I moved along x axis, right? And how many units? X number of units, right? And then Q to P1 vector कितना है? So Q P1 vector कितना है? So Q P1 vector is same as OS vector, right? Because they are parallel. This is a cuboid, right? And this is equal to yj cap. And what about P1 P vector? P1 P vector is nothing but same as OR vector. OR vector, that is also, that is from origin to this point, and which is zk cap. Okay, and the resultant of OP vector plus QP vector, so OP nahi, OQ vector plus QP1 vector plus P1 P vector is our it's our question ki what is OP vector, right? Or R vector, right? Okay, so this is equal to x I cap plus y j cap plus z k cap. So if you want to look it in a in a deeper way, you can use the triangle law also. For example, in triangle OQP1, I want to find what is the length of OP1. So to go from OP1, which trajectory I am choosing? I am choosing to go from O to Q, then Q to P1, and so OP1 vector is nothing but xi cap plus yj cap, right? Then I can look in triangle, let's say OP1P, and our OP1P, and the question is what is OP vector? OP vector is nothing but, so in triangle O1P1 OP1P, I let's say I am going along this axis and then along this axis. So I can say this is equal to OP1 vector plus P1P vector. So what is that? So OP1 vector we have already found here. So this is OP vector is equal to xi cap plus yj cap, and P1P vector is nothing but zk cap, right? So in that sense, we can use triangle law to also do this question. Okay. So look carefully. So the point is P, which is at xyz, and OP vector is nothing but xi cap, yj cap, zk cap. So in vague sense, we can see कि एक जो coordinate होता है, a coordinate has the same information. So coordinate, which is xyz, this is the position of the point P in the 3D space. It has the same information as the position vector, which is OP vector, and OP vector किसके equal है? xi cap, yj cap, and zk cap. They have the same information. So our job here is to extend your knowledge, which was in 3D last year, to vectors and how to solve equations using vectors in 3-dimensional space. And let's see what else we want to say about this. So they have the same information. And what is a position vector? We can ask, but if somebody has a question, what is a position vector? So position vector is a vector joining origin O to our point P, okay, to point P. Okay, so this is a vector, position vector. Okay, so let's continue with our discussion. So you can skip all this, but learning how to apply triangle law can be very, very useful when doing questions from 3D or vectors, and it can save you a lot of trouble even if you forget some formulas. Okay, so what is the length of OP vector? So हमने define किया what is OP vector, right? What is the length of OP vector? What is the length of OP vector? So what is the distance of origin from 0, 0, which is at 0, 0, 0 to point xyz? Well, it is root of x square plus y square plus z square. So I will mark these as 1, this is 1, and this is 2. So we now know how to define a position vector and what is the distance of the point, which we already knew from class 11th. Okay, so we know the magnitude of the vector also. So there are some properties here. So let me take the screenshot from the NCERT. So the first property here is, so they have defined a vector as in its component form. So let's say a vector is nothing but a I cap, so a1 I cap, So you can call it ax also, right? A1 plus a2 j cap. You can call it ay also, and az or a3 k cap. So these are its components. So let me write here what are scalar components and what are vector components. So let's say I have a vector. Okay. So let's say I have a vector a, which is ax I cap. So ax I cap plus ay j cap plus az k cap. So here ax, ay, az are called the scalar components of vector A, are called scalar components of vector A, so of A vector, and ax combined with I cap and ay combined with j cap and az combined with k cap are called vector components of A vector, are called vector components. Okay, so these are just definitions. Okay, so let's look at this property. So if I want to sum two vectors now, let's say a vector and b vector. So let's say b vector is b1 I cap plus b2 j cap plus b3 k cap. I can just add up the components. So you will get a1 plus a2. So a1 plus b1 and a2 plus b2 and a3 plus b3 with I cap, j cap and k cap. You can do subtraction of the vectors also. You can subtract a1 a vector from b vector. You will get a1 minus b1, a2 minus b2 and a3 minus b3. So if two vectors are equal, so let's say if a vector is equal to b vector, that means all of their components are also equal. So that means a1 I cap plus b1, so plus a2 j cap, so I'm sorry, a2 j cap plus a3 k cap, which is the a vector, is equal to b1 I cap plus b2 j cap plus b3 k cap. And you can compare each. So with I cap, the coefficient on the left side is a1 and on the other side it is b1. So and j cap के साथ में क्या coefficient आ रहा है? This is a2 and this should be equal to b2, and k cap के साथ में coefficient is a3 and it should be equal to b3. So all three components must be equal for if two vectors are equal. If two vectors are equal, हमने पहले क्या define किया था? If two vectors are equal, they should have same direction and same length. Now we are defining it the components में इसका definition. If two vectors are equal, all of the components must be equal. Okay, and if we multiply a vector with lambda, each component will get multiplied with a number lambda. Okay, let's continue our discussion here. There are three properties of vectors and scalars also here. So if we multiply a scalar with a vector, so there are three properties here which are simple enough. You might have seen them year and year and we don't even need to discuss them, but let's just insert them here. So here kmn are any scalar number. So kmn are just numbers that belongs to real number. Okay, and a and b are any two vectors. So first property says k times a vector plus m times a vector is nothing but k plus m times a vector. Okay, so scalars will add. And if you are multiplying a vector which with another m times a vector, which is a scalar times a vector, and you multiply with another scalar, you can multiply those two scalars first and then multiply with the a vector, and you can multiply a scalar with sum of two vectors. So you can multiply the scalar with the first vector and then add it to the product of the scalar with the other vector. So nothing very difficult here. You can try to imagine these using some kind of diagram also. For example, for first one, let's say this is our a vector, right? So you can imagine what will be 3 times a vector plus 2 times a vector? Well, let's say 3 times a vector is this, right? Okay, 3 times a vector, and 2 times a vector is this one, right? Okay, so to add them, you need to keep tail of any of the vector on the head of the other one. So let's say 3a के head पे आप रख दीजिए 2a को, right? ठीक है, and what do you get? You get a vector whose length is 5 times a, right? Okay, you get this vector as the resultant. So let me mark it with a different color. So resultant is, if I add them, so this is the third side of the triangle, right? Okay, you get 3a plus 2a as 5a vector, right? Okay, so you can do all these using some kind of figures also. Let's continue. So now there are some remarks given in NCERT. Okay, so let's write the condition for collinearity. So okay, so condition for collinearity, very, very important. Okay, so if a vector is collinear to b vector, so we have already defined collinear vectors. So collinear vectors might look like this. So let's say this is a vector, and b vector can be of different length, but it should have the direction same or opposite, right? Okay, so you can have this vector also, right? So all these are vectors are collinear, and collinearity का main definition क्या है कि they are parallel or anti-parallel, right? It has nothing to do with the length or the direction, just the vector should be in the same direction or opposite direction. Okay, so if a vector is collinear to b vector, let's say this is our a vector, right? Okay, and let's say this is my b vector, let's say almost half of its length, so let's say half of its length, but in opposite direction. So I can construct a vector by multiplying b vector with some arbitrary, so not arbitrary, some specific real number lambda. So lambda belongs to real. So this here is the main definition. So let's imagine what I'm trying to say. So if I multiply, for example, in this particular example, so this is an example on the left side. In this particular example, if I multiply b vector with a negative, तो उसका क्या होगा, डायरेक्शन उल्टा हो जाएगा, राइट? एंड इफ आई मल्टीप्लाई विद 2 ऑल्सो, उसका लेंथ भी सेम हो जाएगा, राइट? ठीक है, सो देयर एग्जिस्ट्स, सो a and b आर कोलिनियर है, राइट? ठीक है, a and b आर कोलिनियर because they are parallel or anti-parallel, and there is a number, right? There is a specific number. For example, in this case, this is -2, right? Okay, so if two vectors are collinear, you can always say, you can form, so I can write a statement here, we can form b vector, a vector from a vector, right? या फिर a vector, we can form a vector by scaling b vector, right? Okay, okay, so this definition will be very, very useful for many JEE questions. Okay, so very, very important. But इसको अगर हम component वाले definition में देखें, so this means, let's say ax I cap plus ay j cap plus az k cap is equal to lambda times b vector, which is bx I cap plus by j cap plus bz k cap, so which is lambda bx I cap plus lambda by j cap and lambda bz k cap, since the vector on the left and the right are equal, right? So the right side पे हमारे पास क्या है, vector, left side में क्या है हमारे पास, vector. So all their three components must be equal as defined earlier अभी हमने डिफाइन किया था उसे. सो वी गेट ax is equal to lambda times bx, which implies lambda की वैल्यू कितनी है, ax by bx. एंड सिमिलरली बाकी के दोनों कंपोनेंट्स है, वी कैन डिफाइन लैम्डा इज इक्वल टू ay by by and lambda is equal to az by bz. So this becomes our condition कि if two vectors are, ये this is a second condition for collinearity, कि if two vectors are collinear then the ratio of their scalar components must be preserved, ay by by, and it is equal to az by bz. So for example 2i cap minus j cap plus 3k cap is collinear with, I can make up an example here, let's say minus 4i cap plus 2j cap and plus या फिर minus 6k cap. Okay, and why is that? Because 2 by minus 4 is equal to minus 1 by 2 and it is equal to 3 by minus 6, and all of them are equal to minus half, right? So this is also the condition for collinearity. So okay, but this here is the vector definition of it, right? This is the vector definition and that is the component definition. ठीक है, components में हमने define किया उसे, ratio of the components. So okay, so there is a second remark here. So we have to define direction ratios. So okay, so second remark here says it's just a definition, okay, and this is definition for direction ratios. So nothing is here. So these are all direction ratios are basically the scalar components, right? Okay, if you have a vector which is a1 I cap plus a2 j cap plus a3 k cap, a1 a2 a3 are called the direction ratios, or these are also the, okay, these are also the, okay, scalar components of vector, right? Okay, scalar. Okay, so nothing very difficult here. So but if you remember हमने last lecture में direction cosines define किए थे, right? Okay, so that is the next thing कि direction cosines. We already defined in this 3D space कि अल्फा बीटा गामा, so cos alpha L M and N, right? L M and N हमने define किए थे, which were cos alpha cos beta cos gamma, cos alpha cos beta cos gamma, and where alpha is the angle made by this OP vector with x axis, and beta is the angle made by y axis, and gamma is the angle made by z axis. So here is our alpha, this is our beta, and this here is our gamma, and we defined these if we are going to point x y z, and हमने define किया था r, क्या था, r was the distance OP, right? Length of OP vector. So r was root of x square plus y square plus z square, and we defined all of these were equal to x by r, right? And y by r and z by r. So we can draw triangles and check that, right? Okay, and for example in triangle OXP we can define cos alpha, right? Cos alpha क्या होगा cos alpha यहाँ पे? So this is the point x, So cos alpha will be base, which is OX, divided by hypotenuse, which was OP, and this was X by R, right? Okay. Because to go to point XYZ, we have to first move X units along X axis, right? Okay. So ये हमने already define कर रखा है, right? ठीक है. So what NCERT has to say कि unit vector is same as direction cosines. Okay. So not particularly, he has not said that, but let's see. So if I have a vector, so in the same diagram, let's see, let me redraw the diagram. Let's say this is our point P, and मैं define करना चाहता हूँ what is OP cap. So we already know OP vector. OP vector is if you are going to point x comma y comma z. So OP vector is xi cap plus yj cap plus zk cap. But what is OP cap? So what is a unit vector to that point? So unit vector are generally used to define directions, right? So unit vector will be of length 1, so OP cap or will be of length 1. But what will be that? So I have to divide by the length of OP. What is the length of OP? Length of OP is root of x square plus y square plus z square from the distance formula, which we defined as r. So what is OP cap? OP cap by definition unit vector किसके equal होता है? Vector divided by its own magnitude, and we get x by r I cap plus y by r j cap and z by r k cap. So we have divided by r, right? And what are all these? X by r is nothing but cos alpha, right? Cos alpha I cap, right? Plus cos beta j cap plus j cap, okay, plus cos gamma k cap. And you can say this is Lm and n. L I cap plus m j cap plus n k cap. So if you divide a vector by its own length, you will get a unit vector. And if you divide a position vector with its own length, you will get direction cosines. So you will get direction cosines, L, M and N, all of these. So direction cosines हमने ऐसे ही नहीं define किया था. Unit vector has a relation. So OP cap has a relation with direction cosines. Okay. So NCERT says it in a different word, but you can read it from here. Okay. But he has not mentioned the word unit vector here. Ki unit vector in the direction of the position vector. So let's go into some examples and let's finish this lecture. कुछ examples देखते हैं and we'll continue in the next one then. Find the values of x, y and z so that the vectors a and b are equal. So if a and b are equal, or if a vector is equal to b vector, we already know then, right? Then all their components must be equal, right? All their components must be equal, right? तो इस क्वेश्चन का क्या रिजल्ट रहेगा? सो वी कैन कंपेयर द कोएफिशिएंट ऑफ आई कैप एंड वी कैन से x इज इक्वल टू 2. जे कैप के कोएफिशिएंट से वी कैन से क्या बोल सकते हैं वहां से? वी कैन से 2 इज इक्वल टू y एंड के कैप के कोएफिशिएंट से वी कैन से z इज इक्वल टू 1. ओके, सो दिस वाज इजी. हमने x y z तीनों निकाल ली बाय जस्ट वी, तो ऑल कंपोनेंट्स मस्ट बी इक्वल इफ वेक्टर्स आर इक्वल, राइट? ओके, सो next question. So some simple questions are there, we will discuss them. So first question Okay, so first question that this question is asking is, is mod of A is equal to mod of B? So A vector, which is I cap plus 2j cap, इसका magnitude कितना रहेगा? Well, it will be square root of 1 square plus 2 square, which is root 5. Okay. B vector, which is 2 I cap plus j cap, इसका मॉड्यूलस क्या रहेगा? इसका मैग्नीट्यूड क्या रहेगा? 2 square plus 1 square. So its magnitude is also root 5. So yes, mod A is equal to mod B. But does that mean are A and B vector equal? No. A and B vector are not equal, right? A vector is not equal to B vector, right? This is the first part. And second part says, is A vector equal to B vector? No, because all their components do not match, right? Because I cap के साथ यहाँ पे 1 है, वहाँ पे 2 है, right? Because components do not match, right? Components are not same. And this can be seen using a simple diagram also. Ki, let's say this is A vector and B vector has some different direction but same length, right? Okay. So even though their length are same, their magnitude is same, the vectors are not same because they are in different directions. Okay. So example. Let's do example 6 here. Find unit vector in the direction of vector, this vector. Okay. So we can find A cap. A cap is defined as A vector divided by modulus of A. So we need to define the magnitude of A. What is magnitude of this A vector? It is nothing but square root of 2 square plus 3 square plus 1 square, which is 4 plus 9 plus 1, which is root 14. Okay, so by this definition of unit vector, divide by its own magnitude, we get A cap किसके इक्वल आ रहा है? 2 by root 14 I cap plus 3 by root 14 j cap plus 1 by root 14 k cap. You can try to find length of A cap and prove that it is 1. You can find कि ये वाला जो वेक्टर है हमारा, इसका लेंथ कितना है? So you can find root of 2 by root 14 square and all these terms. So plus 3 by root 14 square plus 1 by root 14 square, and what you will find is result is 1. Okay. So continuing further, let's do 1 or 2 more examples. So example 7. तो एग्जाम्पल 7 बोल रहा है find a vector in the direction of this vector which has magnitude 7. So how do we, so let's say I have this vector of some length, right, and I want to find a vector which has length 7, right? So how do I find do such a question? But there's an intermediate step. We should find a unit vector in that direction and you should multiply it with 7. Okay, so let's find the unit vector first. So A vector अगर आपके पास given है, आप क्या निकालिए? A cap निकालिए, then you just find 7 times A cap. Since A cap has the length of 1, 7 times A cap will have length 7, right? Okay. So let's see. A vector हमारे पास है I cap minus twice of J cap. So mod of A निकाल लेते हैं, which is root of 1 square प्लस में -2 का स्क्वायर विच इज रूट 5. सो ए कैप यूनिट वेक्टर क्या हमने डिफाइन किया हुआ? ए वेक्टर डिवाइडेड बाय लेंथ ऑफ ए वेक्टर विच इज वी गेट 1 बाय रूट 5 आई कैप -2 बाय रूट 5 जे कैप. ओके, सो हमने पूरे के पूरे को रूट 5 से डिवाइड कर दिया. सो this is a unit vector, right? So vector of length 7 or magnitude 7 in direction of a vector, in direction of a vector will be nothing but 7 times a cap. Okay, this vector will be nothing but 7 times a cap, and which is equal to 7 by root 5 I cap minus 14 by root 5 j cap. So this is our result. Let's say if we have more questions or theory first. So we have example 8 before. Okay, so there are 2-3 questions which we can do on the basis of the theory we have discussed. So let's see, example 8 बोल रहा है find unit vector in the direction of sum of a and b vector. तो ये ठीक है, we can find a plus b vector. So we will add up all the components. तो वो कितना आ रहा है 2 plus 2 I cap प्लस में j cap के साथ में क्या है 2 plus 1 ओके j cap एंड k cap के साथ में क्या आ रहा है -5 plus 3 k cap. So a plus b vector is 4 I cap plus 3 j cap minus 2 k cap. So let me call this vector as some vector c, right? Let me call this c. So हमें क्या निकालना है यूनिट वेक्टर इन द डायरेक्शन ऑफ सी वेक्टर, राइट? हमें क्या निकालना है सी कैप. सी कैप विल बी नथिंग बट सी वेक्टर डिवाइडेड बाय लेंथ ऑफ सी, राइट? ठीक है. और if you want to say it will be a plus b vector divided by length of a plus b vector, right? Okay, what is the length of c vector or length of a plus b vector? So we can take the square root of the squares of the components. So 4 square 3 square plus minus 2 square, which is 16 plus 9 plus 4, which is root 29. So c cap, so unit vector in the direction of sum of these two vectors is nothing but 4 I cap plus 3 j cap minus 2 k cap divided by root 29. So let's write our result. Unit vector in direction of sum of a vector and b vector कितना आ रहा है? So this is 4 by root 29 I cap plus 3 by root 29 j cap minus 2 by root 29 k cap. So एक आधा और एग्जाम्पल देखते हैं. So this is example 9 before we move into more theory. So I'll end this lecture with this video. You can always find the notes below the lecture. Last question for this video. So write the direction ratios of this vector and hence calculate the direction cosines. हमने define कर रखा है direction ratios. अगर हमारे पास कोई वेक्टर है तो उसके स्केलर कंपोनेंट्स या फिर ठीक है ना डायरेक्शन रेशियोज स्केलर कंपोनेंट्स और डायरेक्शन रेशियोज क्या होगा ये सब? these are just the components, right? So these are basically 1 comma 1 comma minus 2, right? Okay, so let's define the direction cosine. So what is the length of a vector? So the length of a vector is root of 1 square plus 1 square plus minus 2 ka square, which is root 6, and we have to divide to direction cosine निकालने के लिए first part second part के लिए, so we have to just divide by that length, right? Okay, so direction cosines is nothing but 1 by root 6 comma 1 by root 6 comma minus 2 by root 6, right? And if you remember मैंने बोला डायरेक्शन कोसाइंस आप कैसे निकाल सकते हो यूनिट वेक्टर से भी, राइट? तो यू कैन फाइंड जस्ट ए कैप आल्सो, राइट? ए कैप क्या होगा you have to just divide by mod of a, right? So it is 1 by root 6 I cap, right, from this and this, right? अब आपके पास लेंथ भी है और वेक्टर भी है, प्लस 1 by root 6 j cap and minus 2 by root 6 k cap, and you can note down these components now, right? So these are the direction cosines. These are the L, M and N, or cos alpha, cos beta and cos gamma. The cosines of the angles made by the position vector with x, y and z axis, and direction ratios are generally represented as A, B and C. So direction ratios are generally represented by A, B, C. So A, B, C क्या है इस क्वेश्चन में? 1, 1 and minus 2. Okay. So see you next time, and hope you are liking these videos. So like, share and subscribe. Again, notes will be available below the video. Thank you.